I am Ranga. I'm the Managing Director for the ASEAN region of Altair Engineering. So I'm going to introduce who Altair is, what we guys do. We're going to talk about the relationships that we enjoy with MAI and other companies out here. And I'm also going to touch upon the global trends in automotive, TPPA, and how TPPA is going to benefit or affect the Malaysian automotive landscape. The NAP, National Automotive Program, which was drafted by MAI, and how our relationship is going to help you people in conducting your R&D. So to start with, who are we? Altair is a 31-year-old company. We started off in 1985, and our vision is to radically change the way the organizations design products and make decisions. So the picture out there is the founder, chairman, James Kappa. So when we started off, the founding fathers of this company were doing consulting, engineering consulting work with the automotive companies in the Detroit area, with General Motors, Ford, and Chrysler. And we continued our journey. We started developing software because there was a lack of modeling and visualization software those days in the automotive segment. While there were a lot of good solvers like Nastran, Abacus, ANSYS, but they did not have a good pre and post processor, no good modeling and visualization tools. So we started off developing what is called as HyperMesh, which would read in the data from any of the CAD platform like CATIA or IDEAS, NX, ProEngineer, and so on. It can read the native file formats and then write out the files for any of the CAE solvers like ANSYS or Abacus or Nastran. And then we continued to add more and more tools to our portfolio, either by organic growth or by inorganic growth. And today we have a number of tools and services that we provide. Though we diversified, we still have we've retained a strong legacy of services. We have over 700 plus engineers, designers, scientists, and creative thinkers spread across the globe who help our customers in their product design and development. So I just wanted to pull out a couple of examples, what we guys do to the industry at large. Here is an example. We worked with, Okay, our contribution for this vehicle, Smart for 2, is concept creation, design engineering, simulation-driven design, development and testing, and also to provide the technology strategies. And the good part is, we could save 30% of the development cost, through our association, through our technologies and our domain expertise. Here is another example. So in this one, what we had to do was we had to develop a border patrol vehicle. Okay, so this is a vehicle that patrols at the border between the US and Mexico. We took a platform from Ford, F450 platform. We ruggedized that platform and then built this whole vehicle around that. So it's got very, demanding specification, and the durability obviously was enormous out here. So we managed to, participate successfully in the development of this vehicle. And obviously, it was front-ended by BAE Systems, and we did all the technology work at the back end. So here is another example. where we worked with China, Rowe Automotive. And the good part here is we did everything. We did all the digital engineering out here, and end result was this vehicle went through the physical test right at the first time. Okay. Typically, it takes multiple iterations before the tests are passed, and this vehicle passed the test in the first attempt itself and got 5-star rating. And then obviously we have companies across the globe, be it Korean, be it Japanese, be it American, be it Indian or Chinese or even Malaysian companies using our software for design and development of the vehicles, the full vehicles. Okay, here is another example how we helped Hyundai Motors to adopt NVH technology with optimization. Here is a case of Renault, where we did some redesign. We did some redesign which resulted in weight reduction of different components. Here is an example. So not only the full vehicle and the aggregates, we also work at the component level. So we help companies develop better components, more efficient, very optimized components, which go in and make the aggregates and which in turn make the full vehicle. So we work with Tier 1, Tier 2, Tier 3 as well as the OEMs across the globe to help them in their product design and development. I just want to show you a simple example of the whole life cycle, how the whole process works around a product. So the example out here is a car seat. So it starts off with the requirements and the packaging space that is available in the vehicle. And from there, the OEM starts giving the spaces to the seat developer. The concept design is made. And then you do a number of other studies like the field of view studies to figure out how ergonomic your seat is. And then you do 3D modeling, part assembly, and then do the design validation. There are different types of validation that you do. Start with simple linear static, all the way up to crash simulation. And you do optimization studies, ergonomics, safety and regulation, and then you come down to virtual testing, physical prototyping, and then you do the correlation between the physical prototype test and the virtual simulation or virtual test that you have conducted using the software. And then you finally, put it on the road, and end of the life, you dispose it off. So this, obviously there are other things which the OEM doesn't do. They normally outsource the manufacturing of jigs and fixtures, design and simulation of those as well. So this is just to give you an idea of a product. If you take any product, how complex it is, and it's not like a couple of days, a few people work on it and you get it right. It takes a lot of work. There are a lot of phases that it goes through, and a lot of people have to put their heads together to come up with a product that works perfectly. And none of us want a vehicle that breaks on the road. So what is that in this whole thing? What is that we guys contribute? We guys obviously contribute from ideation all the way, until the vehicle physical testing is done and approved. Okay, approved by the competent authorities. So this is just to explain, from the aggregate level I showed you, starting from ideation all the way till the end. Similarly, for full vehicle programs, we do participate either somewhere in between or in the whole process, starting from ideation all the way to the physical prototyping and homologation. So, that's where our strength lies. This is just a case of a three-wheeler car, two wheels in the front and one at the back that we are working on right now, called Elio, and the prototypes are already made. So starting from program management, specification, designing, voice of customer, to everything all the way till the physical prototyping, testing, is what we have been doing. So just to give you a snapshot of different areas that we participate in. We participate in the program planning, in general I'm saying we participate with different companies in the program planning, in localization and packaging, design engineering, prototype development, prototype testing. And not only that, with the newer demands that we have today with IoT and autonomous vehicles coming into picture, we do take up a lot of design research, design engineering, simulation-driven design, and development of newer technologies which can be adopted into the current scenario. So that's about the services. So we provide end-to-end services. When it comes to product design, it's not only automotive. I put here automotive because that's what is relevant today for you. We are at the Malaysia Automotive Institute, and I presume most of you out here are from the automotive industry, either from the OEM or from the suppliers. But besides automotive, obviously we guys deal with many other industry segments, be it aerospace, be it oil and gas, electronics, and so forth. When it comes to the software, so software is the core of our business now. When it comes to software, as I mentioned earlier, we started off with developing modeling and visualization tool, which was quite neutral to absorb data from any of the CAD software and then write the data out to any of the CAE solvers. But then sometimes in 2005, 2006 time frame, we started acquiring and developing our own solvers. Okay, today we have a full suite of solvers, starting from very basic linear static simulation to a high degree nonlinear explicit dynamic simulation, multi-body simulation, electromagnetics, computational fluid dynamics, and so on, and all the works. The best part is, in all that, what we try to do is we try to put optimization at the bottom layer. So which means that whatever we do, you want to just carry out a simple CFD calculation. So can you optimize it? Can you optimize the structure to be more aerodynamic, for example? So that's the core. The core for us is sustainability. How can we reduce mass? How can we make your product more efficient? Okay, not just reducing mass. While we reduce the mass, our technologies allow you to increase the efficiency of your products. And that's the biggest value that bring in, and which differentiates us from the rest of the CAE product developers.